Okay, good morning, everyone, and thank you all for coming. So, my name is Minchae, and I am a master's student in computer science at Korea University. And I would like to introduce you to our cyber sickness research work at our lab, the Digital Experience Lab. And this work is supported by our sponsor, Korea Electronics Association. So the presentation is in two parts. First, a brief introduction to cyber sickness and current theories in how they occur and methods of measuring it. Then we will introduce you to some of our approaches to mitigating it. So what is cyber sickness? The cyber sickness refers to an unpleasant symptoms such as nausea, disorientation, and eye fatigue when one is exposed to dynamic virtual environment. It is different from motion sickness, which you can feel when you're in a moving vehicle, in that it happens when you're exposed to virtual environment. But similar in that it is caused by inconsistent motion information as perceived by the body. It is a comprehensive term that includes sickness from using VR and simulator as well. And it is estimated that around 60% of population may suffer from cyber sickness to some extent. As such, it is one of the most problematic obstacles to the deployment of VR to a wider mass. Okay, the main popular theory behind cyber sickness is the sensory mismatch. Our body detects motion in many ways, but primarily through vision and vestibular channels. When using VR for virtual navigation, the human brain receives inconsistent stimuli from the visual and vestibular channels. This creates a conflict between these main sensory organs and causes the various unpleasant symptoms. By the way, apparent motion sensed without the actual motion is called vection. And please remember this word as it will appear again later. More broadly, humans may feel sick when the environment they face is not familiar and not consistent with the real world, such as in the image resolution, lighting condition, object responses and latency, and so on. Another theory of VR sickness is the postural instability theory. Previous research found that sickness was actually preceded by postural instability. They have claimed that humans feel sick when they are exposed to provocative and unfamiliar environments. For example, in VR, users' balance skill may not function like in the real world, and this can result in losing balance and a feeling of discomfort. They also found few cases of where sensory mismatch was not observed, even if the subject felt sick. However, whether instability is the result or the cause of sickness is still debatable. The third theory is related both to sensory mismatch and postural instability. The lack of rest frame objects, that is to help the user consistently identify the ground and gravity direction, is often cited as another cause for VR sickness. The ground and gravity direction will be important in one maintaining balance. Without such reference objects, the world may seem inconsistent and mismatched to that sensed by the vestibular organ as well. For example, as you can see in that picture, a large building and a roller coaster scene may act as a rest frame object. Finally, we want to just briefly mention that sickness measurement is important, not only to access its extent, but also to devise a method to mitigate it. Currently, the most popular method relies on symptoms survey, such as the Simulation Sickness Questionnaire devised by Kennedy in 1993. Other methods include online in situ response collection, measuring balance and postural sway, and relating sickness to physiological signals such as heart rate, eye blink, and etc. And even applying deep learning based on collected user data. Next, we introduce you to some of the methods developed at our lab for mitigating VR sickness. One approach also taken by many other researchers is to reduce the amount of the visual motion information, but not the visual motion information itself. In theory, this would perhaps reduce the extent of the sensory mismatch. For example, as the visual periphery is more sensitive to motion, the motion information in the region can be reduced by peripheral blurring or blocking out by reduced field of view. Rotation is known to cause sickness more than linear motion, so discrete rotation or rotational blur have been proposed as well. For us, we propose to compute and indicate the motion singular point, which is the vanishing point of the optical flow that causes visual motion. In theory, the vanishing point or the region around it is where there is the least amount of motion information. It also happens to be the direction to which the motion is going. In fact, there has been report that objects that do not move with respect to the user, such as the virtual nose or eyeglasses, can significantly reduce sickness. But these objects get in the way of the content, and looking at it may interfere with normal content viewing. I'm sorry, but how can I start the video? Yeah. Okay, in this video, we compute the motion singular point and indicate it with a small red dot. Yeah, there is a red dot. Okay, so the user is directed to look at the red dots when feeling sick. We have experimentally shown that this can significantly reduce the sickness. Note that looking at the motion singular point is also mostly coincident with the usual view direction and the direction of the motion. So instead of playing with the visual, one can perhaps manipulate the vestibular and or proprioceptive sense to reduce the sensory mismatch as well. For instance, previous work has attempted directly stimulating the vestibular organ or applying walk in place to provide vestibular or proprioceptive feedback to reduce the sensory mismatch in stationary VR navigation. We have proposed to extend this approach and apply multimodal feedback such as airflow, sound, and tactile or haptic feedback. So in our experiment, we tested the effects of airflow consistent with the direction of the visual motion and vice versa. For example, when going forward, the consistent airflow will be coming from the opposite direction. This can strengthen the sense of motion as sensed by the visual motion and worsen the sickness and vice versa. We have found that while this was true, the wind itself had a refreshing and distraction effect sufficient to compensate the negative effect and actually reduce the cyber sickness. So this graph shows that the wind was effective in reducing sickness compared to the no wind condition for both consistent and inconsistent case, but more for the inconsistent case. This shows that possibility of multimodal feedback acting as to suppress vection to some extent. We take this idea back to the visual modality in our next idea. So visual motion is mainly caused by the optical flow of the features in the moving environment. We hypothesized that by overlaying the optical flow in the reverse direction of the navigation flow, the vection could be cancelled or reduced, thereby reducing the sensory mismatch as well. Theoretically, this can also eliminate the moving experience if it really worked at the perceptual level. But humans will still gain the moving experience because of the cognitively understanding. The figure illustrates the idea. The left shows the forward flow, and the right one shows the reverse. So in theory, adding them could result in zero or reduced sense of visual motion. To make this happen, we compute and estimate the forward optical flow and use this information to generate short animated lines of reverse optical flow and overlay it on the original content. So this video illustrates the idea. So let's take a moment to watch this video. Can you start the video? Thank you. So those white lines you see are the animated reverse optical flow computed and artificially overlaid by the system. Okay. So I wonder if you guys would feel whether sickness was reduced. If not convinced, you can come to our booth and experience both the version without the reverse optical flow and the one with it and compare the effects. Our comparative experiment applied to various contents with different types of motion showed significant reduction in sickness without much degradation in the VR user experience, such as presence and immersion. We also have applied the same technique to only the visual periphery, as the line segments of the reverse optical flow, while effective, are intrusive to the original content. We applied the same technique to a situation where the VR is used in a moving vehicle. Let's take a moment to watch this video. Okay, in this case, the overlaid flow is made same and not opposite as the vehicle movement. The motion of the car is sensed, and optical or particle flow of the car motion is generated and overlaid upon the virtual environment to equate the visual and vestibular motion information. Currently, we are experimenting with many other approaches with promising results. If interested, please contact us via this email or visit our lab's homepage. Thank you.
Thank you, actually. Very interesting talk. Now we're going to have a Q&A session, so you guys can ask questions. We have a mic right there, and Jungha will answer your questions. So, who's first? Anyone? I can go with the mic as well.
Hi, so in the last videos that you showed, the reverse optical flow is rendered as these sort of like small white flickering segments.
Yes.
To my eyes, it looked a bit like kind of just speckles in the periphery. And I was wondering if this was something that you arrived at after trying other types of visualizations.
Sorry?
Yes, I just don't want to scream into the mic. Did you try other visualizations of the reverse optical flow before arriving at these white segments?
No, we did only the white lines. We had the white lines.
Thank you. Similar type? Yeah. Wait.
I think the white lines would be the least distraction. So imagine if that lines are red or blue. I think it would be too much distraction. Yeah, so we choose to use the white lines.
Maybe we can try more transparent things. It's okay?
Hello, back here.
Hi.
It was actually along the same lines. I was interested in how the context of the environment could potentially impact that sickness or that optical flow, which kind of gets at the same idea that these white lines, are they normally present in a boardroom, right? So if there's a disconnect with the stimulus and the environment, does that potentially have an impact? And did you look into anything like that?
We put optical flow, it depends on the scene, and you can move head movements, and they are scene changed, and it's scene based. Yeah, and optical flow goes scene changed and moved with the scene.
Gotcha. Well, did you try something like a driving scenario, like in a real world, and then counter the flow in a real world scenario?
Real world scenario,
Like driving in a car? So people understand, like, I'm driving in a car, and they have some expectations for how that could potentially be, like, because that's usually the case for simulation sickness, right?
yes, we did it too.
Okay. And did you find anything different?
Actually, they said there are two parts of motion sickness, and first thing in real world, like driving car, there has vestibular system information, and it will be great. It helps when not reverse optical flow, just the optical flow helps it
Okay.
to reduce mismatch of sensory.
Nice. Okay. Thank you.
Thank you.
Thank you.
Vincent Hernandez from American Bureau of Shipping. I like the presentation. I like how you did visual stimuli as a red box to actually reduce or cancel out vection. My question to you is, did you use other means of stimuli, sensory stimuli to compensate other than just the visual? An example, if a person is sitting in a vibrating chair, did that help other than the red box?
Yes, it helps reduce motion sickness. But I think we told participants that if you got sick, see the red box, and they told that it helps reduce motion sickness. But I think it can be a distraction of the content. But there may be trade-offs thing, immersion and reducing cyber sickness. And maybe it can be optional part, like severe. The person who have severe motion sickness can put this point in VR content, and who are not severe on motion sickness can take off this point. That will be fixed. That will be great on trade-off part.
Hey, how's it going? So with the reverse flow, it's very similar to music, but like with the specs, is there any way you could do like blurs? Like, you know how there's like a blurred line instead of the white specs, just do like blurred flow visuals go in the upper direction that are a little bit more transparent, although they distort the image. Thank you.
Sorry. Can,
Yeah, I saw her face.
Oh, so it's like, you know how you had the blurred peripheral around the image? Well, instead of the specks being like white specks going the reverse flow, is there any way those specks can actually be blurred, like blurred flow images of what's going on, instead of just the white specks?
we can. Do you have time? And I'll tell you about this. This paper, this research. If you come our booth, I want to tell you more detailed things about it.
Okay.
Okay.
Thank you so much. Appreciate it.
Thank you.
Okay, any more questions?
More questions, just one more second.
Thank you. I was wondering if you've tried combining the different effects, because so I see the red dot, and of course the red dot's too much, but for a heads-up display, some sort of really cool futuristic thing, you could use it, and it looks like it's almost like a software that you're using, and it'll be more subtle. It won't be so obvious. But that, along with the wind, along with a subtle effect, I think, have you tried combining all of them in once and just see if that helps overall?
Actually, we didn't combine it, but it's just my opinion. It's my opinion, but I think it will be effective, but when we use VR content, this airflow is not everywhere. Yes, and I want to fix it with visual factors things, because the sensory mismatch is just a relation of vestibular system and visual things, and I want to fix it with visual factors only.
Yeah, I think that is a good idea. So yeah, I'm gonna bring the idea back to our lab and think about it. Thank you.
Well, thank you so much. Our time is up. Please give a big round of applause to Minchae and Yoo-Hong Kim.